Hi, my name is Scott Leonard. I'm with the innovation team here at Vapotherm, and we're going to be doing a little experiment today to take a look at the flow velocity from two different cannulas. We're going to be using a tool called a hot wire anemometer. This is a Bluetooth device that allows us to read out the speed of airflow onto the phone. Now, we're going to be using this to measure the flow through, there's a small test section here. The flow will be moving through there. The device is intended to measure wind speed, that sort of thing. So it actually has two sensors. One measures the room temperature, the other measures the temperature as it flows across a hot wire. And as a result, we're going to get a little bit of a shift in our measurements. It really should be measuring the flow temperature on both of these sensors. So we will get a comparative number, but we won't get the exact velocity in any of these. So we're going to get a relative comparison between two different cannulas. For both cannulas, we're going to be running at 25 liters per minute. And then we're going to be measuring the flow as it passes right through the center of this device. It's important that we find right at the center of the flow. We have to adjust this around and find where we measure the maximum speed because that's going to be giving us the most accurate measurement possible of what the wind speed is as it's passing through the sensor. And then we'll be reading out that display on a phone. That's going to be able to tell us what the velocity is as we set up each of these. To do this, we're going to be fixturing both of the cannulas into a ring stand here, which is going to hold both the sensor and the cannulas consistently so that we can get good measurements off of both. So these are the two cannulas that we'll be testing today. We have the Vapotherm adult size cannula, and then for comparison, we're also going to use a larger bore cannula. We're aware that some of our clinicians are using different cannulas on the Vapotherm devices, and we want to make sure that you're aware of the differences that those can have even when the flow settings are the same, that there's a difference in the velocity. So this is for educational purposes. We want to show that there is a difference between these and what that difference might mean. To begin, we're going to test the Vapotherm cannula. So we have it positioned here with one of the nares pointed through the test section of the hot wire anemometer, and that's indicating a wind speed of 66 miles per hour. So that velocity, that's a very high number. That's one of the key features of our therapy. It's like putting your thumb over the end of a hose. You still have the same flow rate, but you have a higher velocity coming out, and that's what's going to be flushing the CO2 out of the airway. So now we're testing the large bore cannula, and you can see that we have the flow from one of the nares going through the test section of the hot wire anemometer, and we're reading out a speed of 25 miles per hour on the readout here, which is significantly lower than the 60 miles per hour that we saw with the Vapotherm cannula. So that lower velocity is going to result in less kinetic energy in the airway, less turbulence in the airway, which is going to reduce its capability of flushing CO2. So even though they're running the same flow rate of 25 liters per minute, there's a significant difference in their ability to flush CO2 from the airway, and that's why it's important to continue to use the Vapotherm cannulas when treating your patients. So this is very significant because the velocity of the flow is going to be what enables us to flush CO2 from the patient's airway. So maintaining that very high velocity is really important for removal of CO2, especially when the patient is breathing rapidly, when you have a very short period of time to flush the CO2 from the patient's airway. So keeping that high velocity is going to be very important. It's more than just the flow rate, it's also that velocity that's doing the work for removing CO2.